All right. Well, hello everybody, and welcome back to BLISS 2025, day 2. Welcome back to our live stream viewers as well. We've got the stats from the day 1 check-in. 50 attendees from 23 travel origins, representing 20 nationalities, including 5 continents, missing Antarctica and South America. So yeah, that's an increase on last year. So we're very happy to see that. On the wallet side, the most popular wallet for check-in was Paytaka, with 24 attendees, 15 for Celine, 6 for Cashnize, 3 for Zapit, and 2 for Electron Cash. So that's a little bit of free market proof of product right there. A reminder that we're going to do the BCH bank run tomorrow, so prep your deposits. You can still buy raffle tickets. And a shout out to our sponsors, Mike Komaranski, the Bitcoin Cash podcast, Commercial Kitchen Stop, Ravish Off Ocean, BCH Bull, Mini Satoshi, Molecular, Turek, Steve Thurmond, and BLISS 2024. You all got your Velma edition BLISS magazines. They're very limited edition because the final print version was 1 or 2 versions out of date. So the schedule has been updated, but the finished version is also available online at bitcoincashpodcast.com/column.pdf. Just a couple of small minor tweaks to that with the correct schedule and so forth. All right, straight into it for today. Our first speaker is Rosco, author of Revoke.cash, one half of the CashScript team, representing the Netherlands.
Thank you. Hi everyone, I'm Rosco, and together with Mathieu I work on CashScript. And today I want to talk a bit about something that we've been working on for the past half a year or so, and longer if you count sort of what led up to this. But first, for who doesn't know, what is CashScript? CashScript is a high-level language for Bitcoin Cash, so that means that it allows you to write smart contracts in a streamlined way, which leads to fewer errors, faster development times, and easier integration within modern applications. And then we're also looking at what is debugging. And when you're debugging, you're kind of trying to figure out what is going wrong inside your programs. And when you're looking at Bitcoin Cash transactions, there are sort of 2 types of errors. Either there's a bug in your transaction building, so in your sort of application around your smart contract, or there's a bug in your smart contract logic itself. And when the bug is the first case, so it's in your transaction building, in your regular application logic, there are quite good tools generally out there to debug regular JavaScript or Python or any other normal code. But for CashScript, it was always pretty hard to figure out what was going wrong in your smart contracts. And that is why we have been developing better debugging tooling for CashScript. So a bit of history. In the past couple of years of CashScript updates, 2023 we had the cash tokens update, and we introduced our new transaction builder. This new transaction builder made it possible to develop a lot more complex and sophisticated programs on CashScript that combine different smart contracts together. That's something that we've seen being developed. A lot of the new modern smart contract applications have multiple contracts with different logic that they combine into a single system, and that's something that we needed to support. So that's what we did in 2023. Then in 2024, with the help of mainnet Pat, we were able to launch the first version of the debug tooling that I'm showing you today. That worked pretty well, but there were still some caveats, and it didn't work with our new transaction builder, for example. And then this year, we've released a new next version last week, which is feature complete with everything I'm showing you today. And we will be launching the production version in the coming weeks, most likely. And that introduces these debug tooling for our new transaction builder, and it just kind of streamlines and irons out a lot of kinks in the previous iteration of the debug tooling. So, like I said, this is going to be our upcoming release, CashScript v0.11, which is going to have support for the new BCH upgrade that we'll see tomorrow. Like I said, we're adding debugging to the new transaction building. And the third point is a pretty important one as well, that we're using the optimized source code for debugging, or the optimized source map for debugging, rather. And what that means is that in the previous iteration, if you were using our debug tooling, it would use some unoptimized version of the bytecode. So there was quite a bit of confusion there, where people didn't really understand why their production bytecode was different from what they were seeing in the debug tooling. And that also meant that it was pretty hard to debug introspection and more complex smart contracts. So that's all ironed out now. So you're able to just use your production contracts for debugging. And with this release, we're also deprecating the older transaction builder as we're sort of moving everything to our new transaction building flow. So in early CashScript debugging, this is kind of what you would see. If there's something that went wrong in your CashScript or in your smart contract transaction, you'll see like, okay, mandatory script verify flag failed, and you might see any of these things, script failed on up verify operation. I mean, like, you kind of understand that, okay, well, so something somewhere went wrong, but most CashScript smart contracts have a dozen different verify operations, so try figuring out which one of them failed. So I think in the early days, that meant that you would be like copying or commenting out different lines to see if that would make the contract succeed. And when something like that failed, you could use a tool like this, like Meep, where you can jump in and go to the actual opcodes, but that looks kind of like this. It's not really the easiest way to figure out what's going on, and there's no like mapping between this low-level code and the high-level CashScript, so it doesn't really help you understand what you need to change about your CashScript code. So cryptic unhelpful errors, it was very hard to find where exactly it failed. No clear mapping, and also no error messages or logging that help you get a better idea of what's going on in the contract. This is the replacement of the error you saw earlier. So now if something fails in your smart contract, it shows you exactly which require statement, so which verify operation, at which line in which contract, which input failed. And it even shows you the statement, the exact statement in your smart contract code that failed. So you know exactly where to look. And it then shows you a link to the BitAuth IDE, which is a great project by Jason Drazener, which is a much more interesting, or a much more streamlined way of debugging, similar to Meep, but a lot easier to use. It's a bit hard to see right now because of the lighting, I guess. But here you actually see the opcodes on the left with a source mapping on the right. So you see exactly how the compiled code maps to the original source code. And on the right, you see sort of the execution there. So you see where it fails. You can see the stack at every point in time. Nice. I will just leave this slide up for a little bit so you can see it once the blinds go down. But so this essentially means that rather than having to dig through all of this to figure out where things are going wrong, what the stack is at the time, and then I guess having to figure out what that means for your contract code, like your original source code, you can just have it side by side. So you see, okay, well, on the right, you see exactly where it failed. So it says program failed on verify operation. You can see the exact line and the corresponding bytecode for that. So that means that the current debugging has specific understandable errors, so you know exactly on which line which statement is failing. We have integrated tooling without extra setup, so if this fails, you will automatically get this link to the BitAuth IDE, where you will be able to see the source map or the source code right next to your compiled code. And then there's custom error messages and logging functionality. So you're also able to add console log statements to your smart contract code, and those logs will actually be shown when your transaction is being executed. So if you kind of want to know what the value is of certain variables at certain places in your smart contract, you can easily log that. Then besides that, we've also introduced the CashScript testing suite, which makes it a lot easier to test your smart contracts automatically. So we've created a mocknet, which is sort of a local execution environment for CashScript or for Bitcoin Cash transactions built on libauth, again by Jason Drasner. And so that means that we don't need to actually connect to a testnet or run a Bitcoin Cash node in rec tests in order to debug or evaluate our transactions. So for testing setups, this is really useful. It's super fast. And so then with that, we can create automated test cases. We've added some integrations with Jest, Vitest, some other testing libraries where you're able to create assertions that, for example, certain require statements failed or succeeded, certain things might have been logged, and those kinds of things. So these are some snippets from the automated testing of AnyHedge that I wrote way back, and I remember that this was really, really a pain to put together. Because we were essentially just trying to piece everything together to make these transactions run locally, figure out what happened there. And with our new testing suite, you can basically just do it like this. So we create a new transaction builder, we add inputs and outputs, and then we can just say we expect this transaction to log a certain thing, or we expect this to fail or require with a certain error message, or not to fail or require statement. And so you can put all of your sort of edge cases where if we provide certain input parameters, we expect a certain require statement to fail, or we expect a certain require statement to succeed, or we expect the whole transaction to succeed. So, and with that, you can basically map out all of your edge cases to make sure that your contract works the way you're expecting it to work. And this just all runs locally. It's just executed locally, so these tests run in no time at all, essentially. If you want to get started with CashScript and the new debug tooling, we've also updated our CashScript Playground, online IDE tool where you can do your development. And so this has now also been updated to work with a new transaction builder, so you're able to combine different smart contracts that you all write inside the CashScript Playground. You can combine them all into a single transaction. You can use mocknet, so you don't actually have to have any testnet BCH or mainnet BCH to use these tools yet. So if you're just playing around, it's super easy to say, okay, I just want to use a mocknet with these specific test UTXOs to see if it works. And in case something in the transaction building doesn't go as expected, you will also see these specific error messages from our new debug tooling with a link to the BitAuth IDE if you want to dig into it deeper. So, like I said, we're launching the full release of this debugging tooling in the coming time. And after that, we have some short-term and long and medium-term plans for the CashScript project. We want to have better integration with Wallet Connect. You're already sort of able to figure that out, but similar to the debugging, it's a lot of manual work to get things working. So we kind of want to have integrated Wallet Connect tooling. Then there's a lot of things in the CashC compiler that have been in a certain way, since it was basically created in 2019, that we kind of want to refine to make sure that everything that is there for a reason and not just because that's the way it was done some time ago. We want to extend the mocknet as well to make sure that you can use it for more use cases and more complex operations where you might not only care about one single transaction, but you might care about testing whole flows of transactions, which is currently could be possible with mocknet, but again, those kind of things we really want to streamline. Then in the medium term, we want to take another look at the language itself, and we want to do some more work on that so that we can support custom data decoding in an automated way with structs. We want to add loops when that reaches the consensus upgrade as well, and things like macros or libraries, either when we get something like op eval, but also there's things that we can emulate before that time. So those are kind of like our plans. And yeah, if you want to try out the new debugging tools, go to the CashScript Playground. We'll also have a workshop later today in the afternoon where people can get started using CashScript. So make sure to check that out and join us if you're interested in trying out CashScript. This was Debugging with CashScript. I'm Rosco. Thank you for your time.
All right, do we have any questions here? I've got a question, which is you mentioned the op eval as well as the other potential upgrades coming up. You're in a pretty good position to weigh in on these at an early stage, being close to the metal on that. What do you make of particularly op eval, but also the other two?
I think it would make a lot of things easier for smart contract developers, for sure. I'll weigh in on that perspective. I'm not too maybe well versed on the world outside of the smart contract ecosystem, but definitely there's a lot of things that would become easier with something like op eval. I think something that we see quite a bit, or that we have seen with people developing on CashScript, is that they're developing their own macros. So if there's some part of code that is repeated in multiple places in the smart contract, then rather than copy pasting the same code, they want to be able to have just a simple function or macro. And people are doing that sort of manually now. So we definitely want to build the infrastructure for them to do that in an integrated way. But even if we add support for those macros, it's going to be pretty inefficient because under the hood, we'll still be copy pasting over the same code 5 times. So using op eval for that will, I think, reduce the strain on the network, because there will be smaller transactions and the code to be executed will essentially be the same, just with less bytecode needed for that. So yeah, I think it will be definitely will be able to see more interesting applications with something like that.
Okay, and a similar, or well, unrelated question, but it's kind of in the same vein, is you're also involved in the Ethereum ecosystem, and we've been seeing BCH catch up over the last couple of years in a big way to where the Ethereum DeFi ecosystem and tooling and wallet infrastructure is at. What do you make of that, and how do we start attracting devs over from the ETH side?
So I think that the difficulty is that the mental models of Ethereum development and BCH development are just very, very different. In the past, there were a lot of things that you couldn't do on BCH as well, or that you could do with a lot of workarounds. I think today there's a lot more that you can do, and can do more easily with the last couple of years of network upgrades and having that integrated into CashScript. I think there's a lot that you can do, as we saw, as we've seen also in the new stablecoin projects that are being introduced. But at the same time, the mental model of Ethereum is, I think, for a lot of people, a lot easier to reason about, because it's kind of similar to how a lot of other things in the digital world work. If your bank account has a balance, you don't have a bunch of coins in your physical wallet. That's not really the analogy that a lot of people work with these days. And additionally, because of the way the Ethereum model works, it is a lot easier to develop tooling around that. So while we have CashScript now, which is a lot better than it used to be, it's still a lot more work as well for us to improve that tooling for the developers than it might be in Ethereum. So I think it's still quite the challenge to get people to take a look at other ecosystems.
Yeah, okay, but I think we're on the right path. I think we're getting there step by step. All right, put your hands together for Rosco. Thank you.
Yeah.
Good.